Hello, we are Wesley, Ari, and Perpetua. Uh, we are part of the course of Design and Analysis of Algorithm. And this presentation is about a kind of challenge, code challenge, and we are here to explain them. To, to start with challenge, we are about to explain the first one that is about exponential power calculation, but using the division and conquer approach. In this problem, we need to compute the b to the nth power, where b is a non-negative real number and n is a non-negative integer. Uh, and after that, we have to extract the most significant digit along the order of a magnitude in base 10. In other words, given this, this kind of input, uh, where 2 is b and 1 is n, we have to calculate the 2 elevated to the n in power and share to the user the output of the 2 and 0, where 2 is the most significant digit and 0 is the order of the number uh, that we raised by this calculation. The algorithm reasoning works this way. In this case, we have to use the division and conquer approach. And for this, is expected to use the recursively way to code. Okay, but we start with the base case. In the base case, we have two base cases. If the n is 0, then we return 1, since the any number to the power of 0 is 1. But if the n is 1, then we return the base, that is b. Okay. Uh, in the recursive strategy, we have two cases also. The first case is if the n is even, so we compute b to the exponent n, but n is divided by 2. We do this recursively and return each square. So the result of this computation, we compute in sequence the each square. But if the n is odd, we compute b to the exponent n, but the n is divided by 2. But this division here, we catch only the integer part of the result. Okay, in recursively way, in sequence we square it and multiply by the base. Here we have some examples to illustrate the case. In the base case, we have b as a base and n as the exponent. So since the n is 0, then we return by the definition of the base case. And our result is b to the 0 and return 1. But if the b is 2 and n is 1, we can relate it to the second base case. When the n is 1, then we return b. After that, we can explore the case when the exponent is even. So we have b equal to 2 and n equal to 2 also. Note that n is even, so we compute the power that way. Power 2 to 2th power as power of 2, and we divide the 2 by 2, and the result of this computation, we can compute the square of the each computation, okay? So uh, by the definition, when we get the division, we have this result, power 2, 1, and we catch the each square. The result in that case uh, return to us the base case when the n is equal to 1. So when the n is equal to 1, we return b. So we return the base, and our final result is 2 uh, multiplied by 2 is equal to 4. Or 2, or power 2 and 2 is equal to 4. But if the n is odd, we have this case. Uh, if n is odd, we compute power 2 uh, to the exponent 3 as power 2 to the exponent 3 divided by 2. In this case, we catch only the integer part of the result. Okay. In this result, we compute the the squares and multiply by b, by the base. So we have 2 to the exponent n 1, that is the integer part, compute the square, and this result is multiplied by b, that is the base. Okay, so the final result is 8, and that is 2 to the exponent n 3 is equal to 8. Okay, but we have to export uh, another extraction to return the result as is asked. We have to return the uh, the most the most significant digit of the result and the magnitude of the result. Okay. To do that, we have to compute the first way. We have to compute the order of the magnitude. To compute the order of the magnitude, we have to compute the log uh, in base 10 of the result of the power. So to get the exponent in scientific notation, okay? And after that, we can get the floor of the result or just the integer of the result. After that, to compute the most significant digit, we divide the the result of the power of the exponential uh, by the 10 to the power of the order that was extracted in this step. Uh, to illustrate that, we can explain with this example. We have the base 2 and the exponent 10. So we compute 2 to the exponent 10 is equal to uh, 1024. So to calculate the order of the magnitude, we can calculate the log 10 to the number, and we extract this number. Okay, but we want just the floor or the in part, so we can get or catch just the 3. That's the integer part of the result. That is our magnitude, our order of the magnitude of the of these results. Okay, uh, and the last part is extract the most significant digit. To extract the most significant digit, we divide the result by the 10 raised to the order, in other words, 10 raised to the 3. So we divide the result by 10 raised to the 3, and we get this result. But equally, we have to extract just the integer part. So the most significant digit for this result is 1, and the magnitude is 3. The complexity analysis for this algorithm uh, bring us to the O log n, since the exponent is held at each step. In other words, the exponent, the computation uh, is, how can I say, we can compute the exponentiation by dividing uh, the result by 2 until we get the base case. Okay, so for for this reason, our complexity is O log n. Okay, Perpetua, you can explain the code.
Sure, I'll go next. I'll share my screen. Okay, so I am going to explain the code. This problem, well, we solved it using Python. It has three main steps. The first step, you're going to understand exponentiation using divide and conquer. And then the second part, you're going to extract the scientific notation information. And then the third part, you're going to be able to read the input and run the program. So this function is the divide and conquer function. Here, this is the function. So the first thing we're going to do here in the first step, we have to determine the base cases and the recursive cases. We have to work on those. For the base cases, we are going to check whether the exponent is 0 or the exponent is 1. Those are the base cases. If the exponent is 0, we will return 1. But if the exponent is 1, we will return the base, which is our b. And then the second part, we are going for the recursive cases. If the exponent, we have a method that will check whether the exponent is an even number. If it's an even number, this it will check whether the number is even, and if the number is even, it will compute the result recursively and then square it. But if the number is odd, it will do the same, but it will multiply. It will multiply the result with the base here. And then now we'll go to the second part that will extract the scientific notation. For that, we'll check the most significant digit and the order of magnitude. So this is the function for it. Here, we'll check the most significant digit and the order of magnitude. If the most significant digit is 0, our result will be 0. If the order of magnitude is 0, our result will also be 0. And then here, we have the method that checks for the order of magnitude, and it will check for the first digit. It will tell us how many digits the number has, And then for the most significant digit, we have this method, and finally using the int function, we'll be able to convert it into an integer, and it will be able to give us the first digit. We'll print the most significant digit and the order of magnitude. And then finally, we should be able to read the input and run the program. That is the work of this part. The program will read two space separated values from the standard input. We have a floating number, which is b, and then we'll have our integer n, and then the program will give our output, which is bn, which will be separated, and it will convert them into the appropriate types that calls the output function.
Okay, so that's the first problem. I will explain the third problem. I will share my screen. I will explain the grid algorithm to the max discounting Black Friday problem. The problem was basically a sale when you buy 3 items and just pay for 2 of these items. And we have to create an algorithm to decide the best way to divide your products to get the best discount. Here in input, it's a example of an input. If you have 10 items in your problem, we have to separate this input in times of 3, and by the output indicating the max discount we have here. So here it's some examples. If we have 10 items and the prices goes from 1 to 10, we have to sort this array descending and do some group of items, some free items. And the algorithm reasoning was first step, we have to sort prices in descending order. So we use the array that have the prices and sort this array descending to guarantee we have the most valuable discount in each by we doing this star. We do the sort prices in descending order because the product that have the cheapest price, the cheapest one is free. So when we order by descending, we guarantee the max discount in the 30 item. So the second step is group items. So we have to group the items in group of 3. And in each group, we will choose the smallest price to be free. And the sum of these 3 items will be our output. And in this algorithm, we are considering the the input of this values only accept the integer values, and the efficient of this algorithm, uh, we do the sorting using merge sort in the first example, and the second example we use built-in sort, Python sort. I guess in the after 3.11 Python, it's the power sort they use natively. So we use in this in the second example. And the complexity of this algorithm is the sorting is O n log n, and the sum of the third item is a no n operation. The code structure I wish to show to you next step have the merging sort implementation and the discount calculation. The method sort is a function implemented to generate the merge sort in choosing the ascending or descending order, and the function max discount show the prices, classify the prices and in the descending order, and iterates over every third element, and then compute the total discount. Two examples here. If the input was 10 items priced by 1 to 10, they start descending, so it will be 10 to 1. The free items every third element, so we have a group 10, 9, and 8. The 30 item it's free, so 8 is the free item. Next to 1 is 5, and next to 1 is 2. The last one not from a group, so there's no free items. And the total discount is the sum of these free items. And second example, it's not a ordered list, but we have to sort. So if we have 8 items and sort this descending, group it by 3, get the last one to generate total discount. This resolution concises to approach grid strategy. First, ordering the prices to maximize the value of the free items, and after then summing, realizing the sum of this discounts. So the complexity of this algorithm is the sorting O n log n using our merge sort, our built-in sort. It's the complexity is the same, and the sum calculation, the discount calculation, is a linear operation, O less than O n, because we are summing all the third element of the sorted list, and the complexity overall is O n log n because of sorting. Here's the code for small instances. The first method, this function, is the sort function. He do the merge function using it's another function. I will not explain this. It's a simple merge function. And the function max discount, computing the discount. First, they sort the list by descending and iterate the three items of this, getting the last one, sum total. So every three items, the last to the third item uh, will do will increment the variable total, and this variable returns to complete the algorithm. For large instance, we just create the max discount function because we are built-in sort here. The built-in sort guarantee to us the same performance as the crowd exercise wants. So we decide to use them, create the same total variable, and I for loop here, just iterating step three of three steps and get the third item to increment the price of total. And was the second third other exercise. Guys, Wesley and Perpetua, if you want to say anything else, you feel free.
No, it's okay. Uh, so we finish here our presentation, and thank you for your attention. Bye.
Thank you.
Bye.